So here we have an example of a real-life proportional relationship. We have a family drove their car 225 miles in 5 hours. So first we're going to write a direct variation equation that relates the distance traveled in respect to time. Then we'll graph that equation, and then we'll use either the graph or the equation itself to predict about how long it will take the family to drive 360 miles. So first we're able to write the direct variation equation of y equals 45x. We're getting the number 45 when we're looking at the ratio of the y value to the x value of 225 over 5. That gives us 45 over 1. So that's why we're using that direct relationship, that proportional relationship from the situation to go into an equation where y is representing the distance in miles and x is representing the time in hours. So to graph that equation, because it's direct variation, we know we begin at the origin, 0, 0, and then we're using our slope of 45 over 1, but since our y-axis is actually counting by 90s, we're using a slope of 90 over 2. So that would be 290. Then 4, 180, then 6, 270, then 8, 360, and so on and so forth. Now, we can use the graph or the equation to predict about how long it will take the family to drive 360 miles. Well, that means we're looking for when y equals 360. So you can either substitute that into the equation, y equals 45x, and then if you divide both sides by 45 and solve for x, we get that answer of 8 hours. We also can see on the graph, if we look at our y value or our value for d of 360 and we follow it to our line, we see that that ordered pair is 8 360. So that means 8 hours the family will have driven 360 miles. So we can use the graph or the equation to make predictions with this proportional relationship.